Now here's another problem related to histograms. So the variable here is the birth weight of lambs, and this is in kilograms. It's measured in kilograms. There are 32 lambs in this data set, and we have to understand the histogram before we answer any other types of questions. So let's look at the histogram. The x-axis is the variable and the y-axis is the counts. What does that mean? It means that let's look at the second bar. It means that there were 6 lambs of weight 1.3 kilograms. Okay, there were, let's look at the next bar. There were 8 lambs with birth weight 1.4 kilograms. If we look at this bar, it means there were 6 lambs with birth weight 1.6. So the shape of the distribution is roughly symmetrical. Remember, it is rough. Just roughly, that's the shape. It's bell-shaped, so it's roughly symmetrical bell-shaped distribution. There is no prominent skew. Now, we need to figure out the lower quartile, the median, and the upper quartile Q3. So let's look at the sample size n equals 32. Remember that 32 is an even number. So there are 2 middle numbers, and we need to find the 2 middle numbers and take the average of those 2 numbers in order to find the median. So first step is, let's find the 2 middle numbers. How do we get the 2 middle numbers? Since 32 is even, we can divide 32 by 2 to get a whole number. So 2 ones are 2, 2 sixes are 12. So the 16th number and the next one, that is the 17th number, 16 and the 17th numbers are the 2 middle numbers. Now let's try to figure out what these numbers are. We just know the position or the rank, but we need to figure out what these numbers are. So the first number is a 1.2. The next bar says there are 6 numbers. (1.3 kilograms), and it keeps going 6. So the first 7 numbers are 6 plus 1, 7. So the first 7 numbers are either 1.2 kilograms or 1.3 kilograms. Now let's add 8, because in the next bar there are 8 lambs of birth weight 1.4 kilograms. So 8 plus 6 is 14 plus 1, 15. So there are 15 numbers. The first 15 numbers are either 1.2 kilograms or 1.3 kilograms or 1.4 kilograms. We add 8 to this, and that gives us 23. So clearly the 16th and the 17th numbers lie in the 4th bar. So the first 15 numbers are either 1.2, 1.3 or 1.4 kilograms. The next 8 numbers are 1.5 kilograms. So the 16th and the 17th numbers would have to be sitting in the 4th bar, which means the weight is 1.5 kilograms. So the weight associated with the 16th and 17th numbers are 1.5 kilograms. So we take the 2 numbers and divide by 2 to get a 1.5. So 1.5 kilograms is the median weight of the lambs. So there are 16 numbers to the left and 16 numbers to the right of the median, which is really the average of these 2 numbers. So note that 16 is again an even number. So we need to figure out the 2 middle numbers of the left side. So the 2 middle numbers are 16 over 2 and the next number. So 16 divided by 2 is 8. and the next number, which is, so the 8th number and the 9th number are the two middle numbers. So let's see what the 8th and 9th numbers are. So the first number is a 1.2. The next six numbers are 1.3. So 6 plus 1, 7 numbers are either 1.2s or 1.3s. Now we add 8 to that. So 1 plus 6 plus 8 is 15. So therefore the 8th and the 9th numbers lie in the third bar, which is 1.4 kilograms. So both the numbers are in the third bar. So the 8th and 9th numbers are both equal to 1.4. So we take the average of the 8th and 9th numbers, add the two, divide by 2, and we do get 1.4 kilograms. So Q1 is 1.4 kilograms. And similarly, we find Q3, which is the 8th and 9th number on the right side of the median, and that's how you find the Q3. So so the 8th and 9th numbers on this side of the median are the two middle numbers. So this is how we find it. So if the median is the average of the 16th and 17th numbers. So to 17, we're going to add 7 to find the 8th number when we count from the 17th onward. So that would be the 24th number, and the next one, which is the 25th number. So the 24th and the 25th numbers are the two middle numbers on the right side. So we just have to identify or locate. So these are the locations, 24th and 25th. Now we just need to identify what the 24th and the 25th numbers are. So when we go 1 plus 6 plus 8 plus 8, it's equal to 23. So the first 23 numbers are either 1.2, 1.3, 1.4, 1.5 kilograms. So the next two numbers, the 24th number and the 25th number, are in the 1, 2, 3, 4, the fifth bar, which is 1.6 kilograms. Each is a 1.6, and the average obviously would be a 1.6. So this tells us that 1.6 kilograms is the upper quartile. And this is how we calculate the quartiles. Now, if we had to find the mean of all the numbers in the data set, remember the first number is 1.2. There's only one number that's equal to 1.2. So basically what we're doing is we're adding all the numbers, that is all the birth weights, and dividing by the total number of birth weights, which is 32. So this is how we add all the numbers without actually listing everything. We go, there's one number which is 1.2. So 1.2 times 1 is the total of the first bar. There are 6 numbers, and each number is 1.3 kilograms in the second bar. So we're adding all the numbers in a smart way without actually listing everything. There are 8 numbers, each is 1.4. So 8 times 1.4. Plus there are 8 numbers, each is 1.5 kilograms. So 8 times 1.5. So what we're doing here is really adding all the numbers. There are 6 numbers, each number is 1.6. So 6 times 1.6 is the total, plus 2 times 1.7 plus 1 times 1.8. Add all the numbers, put it in parentheses, and divide by the total, which is 32. And the answer, I'm sure it's somewhere here, is about 1.47 kilograms.